In this video, we are going to go over the notes packet on graphing of functions on the TI-84 calculator. The first part, we're going to make sure that our calculators are all set up the same way so we can all look at the same windows. The first thing I'm going to ask you to do is hit Second, Window, and you should see a screen that comes up for your table set. We want our table to start at 0, we want our delta table to equal 1, and our independent and dependent to be set to auto. Once your window looks like this, you can hit Second Mode, which is Quit, and you're back to your home screen. To complete the graphs within the packet, you are going to need to graph in y equals and putting in each function separately, one at a time. So the first thing you're going to do is hit y equals. You shouldn't have anything in here. And we're going to put in a number 4. That would mean that we are going to graph y equals 4. When you hit the graph, to get the graph of it, you'll see that you do have a horizontal line at 4. What you are going to be asked for is to find values within the graph. There's a shortcut to do that by looking at your table. Right above the graph key, you'll see it says Table in blue. To get there, we're going to hit Second, Table, and you will see that you have corresponding x and y values. You can scroll up or down. If I scroll up, I'm going to get into the negative numbers. If we scroll down, we can get higher numbers past 3, 4, 5, and so on and so forth. So depending on the graph, you may need to scroll up or down to get whatever desired values you want in your graph. We are going to graph each function from the points in the table, and then we're going to check our graph to make sure it looks the same. And we're going to fill in the specified information that is asked for. There are 2 vocabulary words I would like to go over first with you. The first one, to remind you what symmetry is. Well, symmetry is basically having the same thing at a different part. So there's 2 options. We can have symmetry based on over a line of reflection. Something like graphing f of x. If we graphed x squared to be f of x, this one has symmetry about the y-axis. If you remember, the graph of x squared looks like a parabola, a U shape, and it is the same thing on the left, on the right. So having a symmetry over the line of the y-axis means that if we look at this y-axis value here, we have the same exact thing on both sides of our graph. A second type of symmetry that you can refer to will be considered symmetry around the origin. When you have symmetry about the origin, it is actually considered rotational as well. Right? The graph is the same after 180-degree rotation. So that looks like a graph. Whoops. of an odd function that looks something like this. If we took this graph and we rotate it around the origin point, which is right there, you'll notice what's in quadrant 3 would fall exactly on top of what's in quadrant 1, and quadrant 1 would fall exactly on top of what's in quadrant 3. So you can rotate the whole thing 180 degrees and you will have symmetry about the origin. So the two different symmetries that you have symmetry about the y-axis and you have symmetry about the origin. So when you have a reflection over the y-axis, it would be the first one. If you have rotational symmetry or 180-degree difference in the picture where it's exactly the same, you will have symmetry about the origin. The other word that's going to come up are asymptotes. To recognize whether a function has asymptotes or not, you need to understand what an asymptote is. It is a line that a function approaches but does not meet. So graphing something like 1 over x, if you actually put this into your calculator, the picture looks like this. You have two curves, one here and one here. And you notice I put arrows on this end. So this arrow to the right, as x goes to infinity, this is going towards your x-axis, but it's never going to touch the x-axis. And on the left, it's going towards negative infinity, but it's never going to touch the x-axis either. So that means that this value right here is an asymptote. And that's at y is equal to 0. That line right there creates an asymptote. You notice also vertically we have another one. The function is increasing towards 0 for x and decreasing towards 0 for x in the positive and negative direction. So therefore this vertical line here is another asymptote. And this is at when x is equal to 0. So this particular function has two asymptotes. Be on the lookout when you do graph that if you see your graph is approaching a value, that could be an asymptote. Asymptotes do not exist as far as in the picture. What happens when you get an asymptote in your chart, it will read as an error. So your table will read error. So quickly, I'm going to show you that on this calculator over here. If I go to y equals, and I put in here 1 divided by x, and I go to the table, second graph, I go right to the table, you will see as I go to 0, there is now an error, right? When x is 0, there's an error. There is no y value. That creates an asymptote. Okay, so therefore, that tells us there's an error. And you can go and you can see in both directions, getting really small. The other direction, it's getting really large. As x is really large, the values are getting much smaller. So it's approaching 0 on both ends. And the graph of that, if we look at it, that's what your calculator is going to give you, but you need to understand that there are arrows on the ends of those approaching the asymptotes. So all of these details and all of these things that the packet is going to be looking for, domain and range, intercepts, average rate of change, all the things we reviewed with an addition of asymptotes and symmetry.